All right, we're on to the next one. Sylvia, what do you got?
10b.
10b, go ahead.
The limit as x approaches 5 over 2
Yep.
of the absolute value of 2x minus 5.
Yep.
And then times x plus 1.
Times?
Yeah.
Mm-hmm.
Over 2x minus 5. And asks you to graph it too.
Oh, good.
Yeah. I think that's what the
Ah, so that's, yeah, it's a one-sided limit. Which way, left or right?
Yeah, it said to use both.
It said to use both, yeah, because, okay, so this is, so it's a two-sided limit, and they're asking us to look at both sides, and we have to, because it's an absolute value, yeah.
I got the graph, I just didn't know how to do the, like, remember in our first lesson, it was,
Mm-hmm.
like, you take the absolute value
Yep.
and you have to show, like,
Yep, I got you, Sylvia. Give me a second. Give me a second. So this is what Sylvia's saying. She's saying that this is the part that was still giving her some hard time. That when we have a function x, absolute value bars x, it actually is a piecewise linear function. And we forget that. It is going to equal x if x is greater than or equal to 0. And it's going to equal negative x if x is less than 0. So depending on the domain, depends on which function we actually follow. And we forget that. We know what it looks like because our grade 11 teachers drilled it into our heads and we memorized it. But we don't truly comprehend that this line here is y equals x, and this line here is y equals negative x. They both go through the point 0, 0, and over 1, up 1, so that's a positive slope, and over to the left and up 1, that's a negative slope. If you wanted to, depending how you're thinking about this, you could consider it going down and you can get the negative slope down there, but that's not part of the absolute value function, so I don't like to do that. So when I do my rise over run here, I'm going this way, which is a negative run, and a positive, which is going to give me a negative slope. And so that's why we get a negative slope here. We got a positive slope here. This is what's happening. When I put in a number like x equals 3, then 3 is greater than 0. It goes in here and it becomes 3. So I go to 3 and I go to 3. But when I put in negative 3, it is less than 0. It goes in here, and what we actually get is negative 3, which gives me positive 3. The absolute value function is an active function. It actually does something to these negatives. It negates the negative, which makes it positive. So I go to negative 3, and I go up to positive 3. So what now is going to happen is I'm going to have a more interesting function. F of x equals absolute value of 2x minus 5. That is actually a piecewise linear function. And it will depend on whether or not what's inside the absolute value bars. We call this the argument. That's the argument of the function. Okay? We call that the argument. If the argument is going to be greater than 0, then it's simply 2x minus 5. If your argument is greater than 0, greater than or equal. But it's going to be negative 2x minus 5 if the argument is less than 0. And I think that makes perfect sense. But then you got to remember what the argument is. The argument in this case is 2x minus 5. So it's going to be x being greater than or equal to 5 over 2. And this one, the argument is 2x minus 5. So it's going to be for all values of x that are less than 5 over 2. So it's the 5 over 2 where things are going to get interesting. Okay? So when I go to do a question like this, and if I'm going to use charts, when I look at all the values that are going to be less than 5 over 2, then my range is going to be dictated. Remember, this was the original. Okay, so if the argument of what's inside here is negative, then I have to put a negative on the outside of the absolute value bar. So this is going to be negative 2x minus 5, x plus 1, all over 2x minus 5. And this one over here, if I want to do the x greater than or equal to 5 over 2, I shouldn't have the equal to because it's a limit. So x greater than 5 over 2, notice the argument will be positive. I don't need to have the negatives on the outside. So this one's going to be 2x minus 5, x plus 1 over 2x minus 5. And you could go ahead and plug in all sorts of values down here, or you could stop for a minute, realize that you could reduce that, and do a much easier problem of negative x plus 1 and a much easier problem of just x plus 1 for whatever values of x you choose to put in. Now these are going to be decimals. I'm not interested in doing that. It'll be long and tedious. That's for homework, not for me. Haha. So you guys can go and finish that off. Okay? That's a great question. Okay? So once again, I'm going to change this. If you need this, you can pause it and then look at it. But what I want to show you is we had this function. We had this question. Okay, and this question, this is a double-sided limit that we're going to have to work with, one from the left and one from the right, because this function here, this particular function, has multiple personalities. It's going to look like this. When what's inside the absolute values is greater than 0. And it's going to look like this when what's inside the argument is negative. This doesn't help me much. I need to change it for x. This doesn't help me much. I need to change it to x. And then you see what we're doing. So for when it's negative inside the brackets, I need a negative out here. When it's positive inside the brackets, I do not need the negative out here, which gives me my two parts to the absolute value function. I don't think I can explain it any better than that. You need to practice it. Throw it into decimals, take a look at it. It's an awesome question, guys. But the biggest problem is what we always forget is that the absolute value function doesn't just magically get rid of negatives. That's the way it's been taught to you. I know your grade 6, 7, 8 teacher, if they ever saw it, they said, oh, well, that just does this. Yeah, you know, it just gets rid of the negative. Don't worry about it. I could strangle them. I shouldn't have violence over the videos. So it does matter. It matters very much. It depends where we are on the in the domain, on what's happening there. Okay, we'll pause there.